Yeah, we're being recorded live, Coffee Compiler Club, blah, blah, blah. We've all heard this before. Most people have. Shows up on, YouTube within an hour or three. I'm losing my voice, as people can hear. I'm trying to get prepped for Burning Man. I have all kinds of shit going on in my house. And I'm deep in the weeds with type theory. So I know Simon has some stuff he wanted to talk about, and I put a bunch of stuff in.
I put mine after yours, so feel free to
Okay,
start.
there's a code block with enums in the front. I don't care. So I'll go down mine because I put it in, because I'm the host, because I'm greedy bastard fun. And this is like me figuring shit out, not necessarily any giant discoveries. So I wrote this section on, structs and fields, and basically doing unification for structs and fields. And let me put it up on, let me put it on the screen. Immediately somebody else wants to pile in, and I have to find the participants and add. Yes. Oh, instantly two people show up. Why were you not there a second ago? All right. Boom. And Dan, where'd you go, Dan? I've seen you even recently. There you are. Fine. Okay. So, I'm talking as a starter for people who don't know, I'm losing my voice. So, here is throat coat and honey and tea. See if I make it. So all week I'm screwing around with recursive types and structures and row polymorphism, and I've gone further than I think I can find papers. Oh, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 papers open on tabs that I've been reading. So I'm trying to get my education in on type theory with cyclic types. And the answer is mostly everyone hates it or doesn't do it. So, and then they play funny with other things. So that's why I'm here. I'm going to throw out what I've discovered, and you can tell me that it's boring and we'll move on, or you can tell me there's something wrong. And if people ask questions because they're confused, well, I am too, and that'll probably help me understand. So it's all good. So struct field types, that first section basically says there are two ways you talked about structs and fields. You define a struct or you use a field. And that's the only thing that I'm excited about right now. Not doing anything with like private public privilege. This is all type theory. I'm not talking row polymorphism, although that extension looks straightforward from here. I've read the papers. I think I can do it. Nothing here except pretty much the normal treatment. If you talk about two different structs and you union them together, which I do in this middle, where I say if some random thing, pick a struct with X is something and a Y field, or X is something and a Z field. There's only the X field is common. The end result has an X field as the common piece. That's pretty normal. You've defined a couple extra fields. If you've selected amongst other things, but the end result of this if is you're only allowed to use X fields out of it. Okay, that's pretty reasonable. The next one down does the other direction. I've referenced an X and a Y field twice in the same expression. When I reference a field, it's now required as opposed to available. And the requirements union, you keep stacking them. I need both an X and a Y on the record type of it. I can't get away with just the X or just the Y. And there's a ... in the type, and that's saying, and you can have more fields and I don't care. Whereas in the prior one where I looked at the two structures I built, because I built them on the spot, they didn't have any extra fields. There's no ... If I unify an open and a closed, or a ... and a regular guy, what I'm doing, and this is slightly different from what the normal treatment is, although my treatment papers are ranging from the 80s to the mid 90s, so maybe I'm out of date, is basically you verify the required fields are all present, or you have a type error. And if they're present, you don't need to reference them anymore. You can just drop them and you just keep the available fields. So my little expression there, some struct has some fields X and Y. I report a type as a pair of the whole struct and just the X field. You can see I can pull it out and type it. The Y field comes along for the ride because it's available. No one's getting rid of it. If I am missing a field, like in the next one down, I'll go ahead and add it in and declare it an error field. So I just make a new type E that's just the error type, missing field Z, and then I add it in. And now you have a pair of a struct with a Z field, and the contents of the Z field is error. And if those errors make it out, in AA at least, those errors make it out to the top level, you have an untypable program, you have a broken type program. If they're all dead, AA will let you live with this type. Just say, yeah, you made a reference to a missing field in dead code. I don't care. You don't care it's dead. I don't care it's dead. We move on. So I think nothing special there.
Is that a good approach though to, you have an error, you know it's an error, the code is dead, but code may be under development.
Yeah.
And then later somebody comes along and they're like, this type before, and it's very confusing.
Right. So I've made this as a conscious decision for AA that you are allowed to have dead code. So you can say in a type safe way, you can say if def Windows, else if Mac OS, else if Linux. And in the else if branches that are dead, you can make references to OS calls that have the wrong kind of arguments or just don't exist. Things like that. So, you know, on a Mac, if I ask for something about a file, I can get something told about its resources. I can't do that on Windows. So that same file open call can't retrieve a field has to do with resource flush, for instance. So all I'm doing here is making a conscious decision that I'm going to let this slide by.
Isn't that something that you might want to turn on in specific cases, but not necessarily, like that is a really interesting and good example, but you know, oftentimes I'm just developing a program and I'm not necessarily dealing with.
Use the field and you'll blow up. Here I'm not using the field in any final answer. Or I'm actually, in this example, I'm using it in the final answer. So this is an error. This program does not type.
Yeah.
If instead I had an if false on this expression, the if false would say, the whole false expression is dead. I don't care. And it wouldn't show up in your final type. And then I would let that slide by. So that's nothing to do with structs and recursive types. That's entirely a design decision I put in AA that says, I'm going to let you type dead. I'm going to carry on with semantic analysis, even in the presence of type errors. And if they show up dead in the end, then I don't care, and we move on. And you know, we could argue that this is a bad example, or I'm doing, as you say, I'm doing development and things are broken, and I don't know because I'm not using the dead thing. But it does mean that because it's not being used, I'm not testing it either. So I'm writing code that is known to be unused.
That's true.
I claim that's already, you know, if you're writing the code and it's not being used, you got to go back to your your testing, your test-driven development there, dude, and go get it.
In my opinion, there is no right and wrong here. It's just a compromise, and for the sake of flexibility of the code.
Right. Yeah. So I'm living with this as a, hey, let's go see how it works out. I'm not far enough along to what Cameron would say, code in anger. If I code in anger and I discover it's in the way, we can always flip it on or off and make it optional.
We're talking about, go ahead.
I was going to say, it's kind of interesting that, is it the case that you can tell which code is dead?
Yeah. At the typing level, there is a strict definition of what is dead. So the optimizer does a best effort and may discover more things, but the typer gives you a strict definition of what he will consider dead or not dead. And that's so you can write a piece of code and run it with and without various optimizers and not have it suddenly decide it's dead or alive or whatever and type differently or not. We'll always give you the same type answer. And in the example I'm highlighting, the code is just the whole top level expression. So therefore it's live. Therefore the typer says you have a type error.
Yeah, the tricky thing here, at least in my opinion, is that you cannot, you don't declare it explicitly. The data and the live code is recovered from the program. It's not like the C macros when you if define it and you evaluate it and compile that.
It's more like constant expressions in C++. If via evaluation of a constant expression, I determine you're dead, then the typer says you're dead. And, you know,
you cannot You cannot explicitly declare what is dead and what is alive.
Right, right. But you can fake it close enough by saying if 0, that's a guaranteed hard, you're dead now. So if you want to make something dead, you can just say if 0 and move on. There are a couple other easy ways to make it dead. That's one of them. All right, let me get
interact
into
with
it.
exports.
I'm sorry.
How does that interact with, say, exports?
I'm
building a library.
Oh,
There is no main function that calls things, so everything's dead until I link it against something.
No, and in the case of exports, I'm going to proclaim that you are listing what is getting exported specifically, and those will therefore be live. So I don't have the module syntax anywhere here. This is not what this is about. But the design of module syntax, at least in my head, is you're going to list it. I am exporting the following things. Therefore, they are live.
That makes me tempted to do something like, if I call an eval, anything that is visible to that eval
If you shove an eval,
has to be alive, because I have no idea. It could have called anything that was in scope.
That's correct. If you put an eval somewhere and you don't limit its visibility, he'll see everything that's in scope. Therefore, they're all alive.
But you plan to have, as part of your eval function, the ability to pass in an environment. So if I want to say, here's your eval, but by the way, these are the only 6 functions you can call.
Yeah, right. Well, the obvious
how do I build the environment for that eval?
Is I'll probably have evals. The default eval will just chop it to nothing, no environment, and then I'll make you pass in something if you want to get visibility on anything. And we can argue what the right boundary there is, but that's just eval versus, in your case, you're talking about eval versus errors.
So you would just do something like eval takes a string and a struct.
And the struct is somehow,
it can call only the things that show up in the struct.
Yeah, for instance, there's some way to go there where eval will be sane. I want to give you the option to shoot yourself in the foot and eval with universe. I'll just make it all live, and you shot yourself in the foot. And that, in fact, I'll probably bring out as the top level saying, and also this guy somewhere in his guts calls eval at the top level and has, at some point, and has complete visibility at all kinds of things. And that's part of the type. So you might also have a function that says, I'm going to call somebody else as long as they don't call eval at the top level, because if they call eval, I don't like that.
Yeah, coincidentally, we just implemented eval 2 weeks ago.
Oh, excellent. All right, I want to see if I can get down to where I have my grief and see if somebody has a bright idea of what I'm doing wrong, or this is the correct answer and there's nothing wrong here. Okay, so recursive types come in like these 2 flavors, one of which everyone hates and one of which everyone loves. So if you name a type, so here's syntax in AA for making a list type, list of A's, is an equal to a colon, which makes it a type assignment. Something, I don't care what. Here's a list of A's as a type. Okay, great. I can write the moral equivalence of this in Haskell or Elm, and I do so below. Or I write something a little more complicated below, but totally doable. And then here's a version where I say f is defined to be a function that takes itself as an argument. This is the classic occurs check fail. I found plenty of them while I was coding this up in Haskell. I'll show you in a second here a bigger example that Haskell fails on for the occurs check. But basically, it makes a cyclic type. In the first example, the cycle is specifically broken by the name. And there is a cycle in the types, but the user wrote a name. That's the hook that breaks the cycle. In the case of the AA type I give, which I'm highlighting there, that is a type I derive without needing a name in the middle. And it has a cycle, and I make up an A as a type, and A is typed as a function from A to B, right? So it's a weird cyclic type, but it's pretty straightforward. It says the obvious things. This function can only be called with itself as an argument, which means it just calls itself recursively to Stack Overflow and die. It's a very boring function, very boring type. A little more flavor there is the whole ISO versus equi-recursive. And it basically means that you canonicalize or you don't. The lattice types in AA are canonicalized, they're equi-recursive. When I'm done minimizing, I get to use pointer equality, reference equality to know 2 types are equal. In in my core AA implementation, my Hindley-Milner types are ISO recursive, cyclic, but ISO recursive, not equi-recursive, and I need a cycle-aware equivalence checker. These two things are equal if structurally they're the same structure and their fields are equal recursively, but they'll cycle, so you have to have a visit bid and test for cycles and shit like that. So it's obnoxious and not the end of the world. So here's the example that got me down this path, which is me trying to wrap AA primitives with a floating point wrapper where I have fields that have the primitives operators buried in them. And it's a way to get away from, or to show up various kinds of polymorphism. So fwrap takes a float argument, returns me a struct, which is the wrapped guy, has the float internally as f is ff, has one operator in here called multiply, which takes a wrapped float, and f star is floating point multiply of the one field in y, which has to have an f field, and if that produces a float, because I'm multiplying a float value here, and a y.f is the other float, and f star means multiply by float, and I get a float out, which I pass in fwrap. So I get a wrapped float out, and I make a sample call, wrap a 1.2. Haskell can't type this. And I've fooled around Haskell and then read up, and all the notes say, and you can't do this. You have to insert a data wrapper, and I'll do that in a minute. AA types are fine. The type is a struct, which has an f field as a float, has a multiple field, which takes a struct as the first argument with a f field, because if you call multiply, you need that f field. Turns out you don't need a multiply field. You just need the f out. You're just extracting the payload bit on the right-hand side. Then it returns a thing that's typed as itself. So there's your cyclic type that blows up standard Hindley-Milner. Here's a larger example where I say, oh, go compute 1.2 times 1.2 by taking the original wrap float, calling this operator multiply with another wrap float. And there's the guy on the right-hand side, I only need the f field out of, I don't need the mul field. So I get this horrible type. And I'm losing my voice. So, I'll be done with this discussion in a minute because I can't talk. Yeah, I get basically an unrolled type here. That's, the outermost guy says, hey, I need a float and a mul, and the innermost guy says, hey, I need a float and a mul, and from the inner mul says, I just need a float, I don't need the mul. And as I wrap these things in multiple expressions, it's clear that every wrapping adds an unrolled layer. And so the minimal type, the typing system ends up counting the layers, counts the depth of the expression, basically. Everyone needs a mul except the innermost guy who does not. In result, the minimal type is as large as the deepest expression, which, yuck.
What terminates the infinite regress there?
I'm sorry?
What stops it from being infinitely deep?
The fact that my expression is constant size.
Ah, okay.
The fact that the code is not infinite.
Yeah. Now, if I loop the code, I think this will become finite sized and loop at the loop boundaries. So I haven't written the example where I use like a Y Combinator to do a for loop, where I just compute like a factorial this way. Like suppose I change this to a wrap factorial version. I suspect I will get a tight wrapping that's reasonable. In fact, I should do that because it helps me with my intuition. So down below the straight line is the Haskell version, which does work, which he makes a data type called fwrap, and multiply takes an fwrap, produces an fwrap. And in core AA, main AA, I can write a data type expression as well, and I line things neatly so you can tell they're almost perfectly aligned. They do the same thing and same meaning. And then here's the Haskell code, which does work. And here's the main AA, which does work. And the core AA is just lambda calculus with a few extensions. And so lambda calculus needs the parens and the long plates. But otherwise, it's the same thing. Like this fwrap call here that I just highlighted, that's the constructor, but it's syntactically a function call. It takes two arguments, the x and the multiply. The Haskell version takes the same thing, except it requires you to name your arguments. That's what mul equals there is about. But otherwise, it just takes the same lambda expression. So what I got out of that was that basically Haskell demanded the user round up the innermost type, approximate it, make it less general, more specific, so that the innermost guy is just an F wrap to F wrap, and the types don't unroll endlessly. Geez. And my email's lighting up with people telling me the power's back on and everywhere but my place. And my generator's still running, banging away off my window. Fine. So I don't like the infinite nesting types. But I might live with it and just say, I'll do that if you do that, and you'll get a deeper type than you might expect. But if but I need to know that if I do like a factorial, that it in fact rolls up. If the factorial rolls up and doesn't try to appeal indefinitely, then I'll declare victory and walk away.
Yeah, we get the same exact result in that at compile time, every time we poke it, it expands one layer, which is not surprising. I mean, my memory is a little bit faint because it's been a few years, but that's the exact same behavior we get, and it's, you know, it's never incorrect.
Yeah, yeah. It just keeps getting bigger and bigger.
Well, it doesn't keep getting bigger and bigger because you only poke it so many times. It's a compile time thing, not a runtime thing.
Right. I mean, your algorithm for computing types terminates.
Exactly.
Yeah. If you don't wrap it, then you will poke it indefinitely as your algorithm says, hey, I've got a new type here. I'm going to run it through flow the type through the typing algorithm, and he's going to come along to a place where he calls himself as a return value from some function. He's going to wrap it another layer, come around and say, oh, I'm not hit a closure yet. I'm not hit a fixed point. I got another type here. You're going to go again, and you'll just peel indefinitely. And I've had that plenty until I got my cyclic types working in the lattice version of AA, where I do have working cyclic types. I quit peeling them forever.
Right. I mean, we only peel them when we peer into them. So if we don't poke it, it doesn't expand.
You're probably listing some types. You're not doing type inferencing. Are you doing type inferencing around recursive functions? Or do you demand that a function has type declaration?
I can't fully answer that off the top of my head, but we do type inferencing, but in general, the type inferencing is in addition to type annotation.
Right. So as soon as you have an annotation, it's the same as the Haskell case. You've broken the cycle with an annotation. And I'll do the same thing. If I have annotation, the cycle's broken, we're done.
Right. But we do have, there is still inference going on. It's just to help improve error detection and code generation.
Right. Within any given region of annotation-free code, starting from annotations, you can forward flow your types. C compilers do this from the 70s. They start with an annotation, but then they forward flow the types, and it's all fine.
Right. We bidirectionally flow, but yeah, exactly.
All right.
For calculating lambda types, for example, not explicitly stated, you may have terminal types on either end, and you may have lambda of lambda of lambda of lambda, and you have to bidirectionally flow until they match.
Okay. So you're doing something like a Henry Miller if you're doing bidirectional flowing.
Right. And we can do all right to left flow. So, you can var, val, whatever.
Yeah. Yeah.
So you don't actually have to use type annotations, but of course it gets sloppier when you do that because you're giving a less finite, it's too potentially infinite from the left side in, if that makes sense.
Well, you need the bidirectional, otherwise, right, you're too open-ended.
Okay.
No, I did that I beat my head on that one in AA for a while before I came around to like Henry Miller exists for a reason.
Yeah, well, I think your goals with inference are dramatically beyond anything I
I'm more robustly trying to do inference here.
Right. I wasn't trying to save keystrokes.
No,
so this is like your recursive types, but with a finite depth, right?
Say again?
This is like your recursive types, but with a finite depth.
This is, well,
it's not that they have a finite depth, it's that they've been expanded to a finite point.
Right.
But they are infinitely recursive. It's just that they haven't been infinitely expanded.
The core problem is how do you type it? What type will you assign to the recursive type?
Here's the simplest one of these recursive types, although I can do the FWrap example if you'd rather. But it mentions A inside the definition for type A. So an obvious unrolling is to substitute all of A in for the inside version, the inside label for A. That's an unrolled type. And then you can repeat that indefinitely. And that's what I'm representing by the infinite type I'm showing. And the normal Henry-Milner algorithm fails because he attempts to do that infinitely. He would otherwise attempt to do that infinitely. And then that leads to infinite expansion, and you can't unify, and it's right.
But you're detecting the cycle and stopping once you found a cycle.
Right. And in my case, I'm detecting a cycle and stopping once I find that I have a cycle. Yes.
So are you representing this internally as a tree or a graph?
The types are represented as a graph, as a directed cyclic graph.
Yeah.
With the ability, obviously, to self-reference.
Yeah, right. And literally, the type I've highlighted is as a struct which has a function input field, which points to the type itself. It's a cycle in the data structure. The concrete representation as Java pointers is a cycle.
Then I guess my question is, what is bugging you about this that you're like, is this the right answer?
The dark, the bolded thing. I would have preferred that I discovered that it wrapped, and it did not. And I stare at it and think, yeah, it shouldn't wrap, but I hate that it doesn't wrap. Because the types, the obvious type that I would like as a user when I look at FWrap is a function that takes a float and returns me this FWrap thing where the multiply takes an FWrap and returns me an FWrap.
But this sounds like exactly the goal that you described earlier, that you, even though the type is, maybe only one level recursive, you might apply it in a context where the different levels of recursion have different arguments.
Yeah,
So you gotta, you can only have it one way or the other.
Well, that was my question. Do I have to have it one way or the other? And I think my answer is I can't have both. So I need to decide that I'm going to do further down the screen here what Haskell says, make a user-defined FWrap, and now you get a nice, tight, concise typing. Or going to let the type expand like the highlighted one now, which as I keep adding expressions that involve floats, it just keeps expanding. As long as it's still finite the size of the program, I'll live with that. Now, that was not my desired answer, but I'll live with that answer.
Right. That's what I was getting at with this is like the infinite types, but finite. I wonder if the problem here is more the syntax that you show than the actual type itself. And that as long as you could represent it as this is this recursive thing, minimum depth 3. I'm thinking of something like a regular expression where you can be like, hey, this is a string that's between 7 and 13 characters, or at least 7 characters.
So what I just,
if you have some way to say this is a depth of 3 or more,
right.
Because the reason you're getting extra layers is because it's not just the recursive thing. It's there must be at least 3 layers and then a recursive thing.
Okay, so the key here for me is that B is a different type than A. It is not the case that I've unrolled A and then a re-rolling, an inverse roll, will bring me back to an A type or a concise type like I had earlier. The B type here, which is in fact identical to the A type here, just because the pretty printer prints A and B in the different expressions, first come, first serve, fine. They end in a ... on the mole guy. And the wraps don't have a ... because they are produced by the execution of FWrap. So here's another way to look at it. FWrap produces a struct that never has any extra fields. But the right-hand side of calling mul can have all kinds of junky extra fields, and I don't care for them. I'm just going to pull the F out of it and then produce you a wrap that has just F and mul. Now, if I were to bring in row polymorphism.
Here, back up a second, Cliff.
Okay.
FRAP produces a struct with at least 2 fields. It's got F and O.
FRAP right here is definition, produces a struct. That's the, you know, ampersand. Okay, those are the 2 fields it produces and none others.
Right. So I guess, I don't know whether this specific example has the property that I was describing earlier. You know, you can imagine, maybe you need to expand the example a little bit, but you know, the structure might alternate between floats and ints or something like
I have a
that.
version that exactly alternates between floats and ends, and it kind of does what you expect. I can paste that expression in here for the type. It's, you know.
So yeah, if you change the FRAP to always, you know, take the floor of the first argument and which produces an int instead, right? Then you'd get your actually no, then it would just turn into the float to int and stay an int.
I did it with my machine got rebooted, so all my open windows got wiped. That's dragging it in there. There we go. There it is. So here is a non-pretty printed version of the universe and this type. I'm gonna go to the bottom here and not do Simon's yet. Sorry, I'm in between. Okay, so throw this in here. Let me go claim Roboto. No, yes, thank you. Oh, come on, dude. What the hell? Fine, something like that.
Do you not still have the formatter in the corner?
Yeah, let me go hit the format button, see if it happens. No, of course I got triple quotes because I'm cutting out a long test case. So why are you highlighting everything? Let me try again here in the format. It's a little prettier. So no, it's different. You can argue I have a wrong formatter up. And he does tab things, so the tabbing's wrong. Here's an FRAP like the above one, except it's called with an operator syntax instead of the word mul. It has an overload, and this is not an overload bug or about overloads. So here's the FRAP using, I'm sorry, here's the FRAP that I have just above. Floating point multiply times the float times y dot f. Here's the FRAP where I take an int value, so y dot I instead of y dot f. And I convert it to a float, and I multiply it, and I get a float out because I'm calling FRAP. So the overload wrapper here is like a red herring. I can just rename all my multiply primitives from, you know, the star operator to multiply int float, multiply int, multiply float int, multiply int float, right? And then you don't need an overload. So the overload is just a syntax, red herring in the syntax. And it's actually working fine in the analysis. And like I said, my spacing is all screwed up because tabs, I don't know, fine. Anyhow, I do this thing where I make a constant integer 2, a constant 2.1 as a float. I make some moles. I do some math. Let me show you the type I get out. It's it's not a pretty type, but it does show the. Let me see here. This. Yeah, something like this. Okay, spacing's all bad. Let me go Roboto font. I need to indent it, and you can tell. But if you stare at there, you can start to see that what I've got here for the first expression. So I made a triple as the answer of multiply integer 2 by 2.1. I should get a float 4.2. Here I am multiplying an integer 2 by an integer 2. Should get an integer 4. Here's a float by a float. I should get a float, whatever, 2, whatever that number is. Okay, fine. And the end result here is I get some A type, which is typed as a float. It's on the wrong side. There's no indentation, hard to read. He has a multiply that takes a B. Well, the B runs all the way here, and that takes an integer type thing and some other shit. And he somewhere I've misdone my spacing here. There's a C. So he's layered 2 or 3 layers deep. So the real answer is he unrolls the int and the float layers, having int and float overloads for the ball options until he gets to the innermost guys. And then he says, oh, and the innermost dude, I just need an F field and a ... I'm going to ignore you. or I need an I field and a dot, 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 and ignore all the other fields. So it's the same problem, just exploded many times out. I end up wrapping layers of overloads of float net, I don't care, that bottoms out as a dot, 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 and just needs the F field. Or just needs the I field. So this is my example I started from because my goal was to say, hey, I'm going to type the thing that I'm trying to get out of main AA in the core language with overloads. And then I got into recursive structures and unrelated overloads. Like overloads are fine. Recursive structures are giving me grief. So going back to the simpler thing, this is a reasonable unrolled type, which is what you saw a bigger version of down below with instant floats intermingled. So I've been cutting the test case down and decide, yeah, I'm going to get inline types here. And I don't like it, but I think I have to, unless the user says, oh, approximate. This is a very general type. I take any float and a dot, 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 approximate that with an F wrap, which has any float and a mole field and nothing else. So it's a more restricted type. As soon as I make that approximation, I'm a closed cycle, I'm done. Fine.
I have a question. So maybe this is just because I didn't follow, so might be a dumb question, but why in that one that you've got highlighted is mul included in the B type at all? Because it's not used inside that function, right? It's only used outside of it. So how did that mul migrate?
Yeah, it took me a long time to figure that one out, and I had to do like step-by-step Henley-Milner algorithm, one step at a time, all the way down the line. It really sucks. It comes because it's a constructed value. Mul is available and unused.
Isn't it as simple as, in this context, you can't tell whether mul might be used down the road?
I don't see why, because
No, I mean, we don't see its use here, but we've constructed something that, has the potential to be used, and we don't know whether it's going to be used yet.
but isn't that everything in a dot, dot, dot has a potential to be used?
The everything in the dot, dot, dot is not used in this answer. It is not usable in this answer.
Isn't that the case here as well?
No, and like I said, you're not a stupid question. It took me a long time to decide if this is correct because I didn't believe it either. And the answer was, I am constructing. I'm sorry. So I get like the one above, that you're going to get a mul field because it's just the return of a function of F wrap as a struct I just made. And that Y gets turned into a struct that has an F field. But when I go another layer, I've called mul. Mul produced me an F wrap result. That's this outermost one. That mul it returned also took an F wrap. That's the inner one. So this outer one just came because I called mul, who turned around and called F wrap. So I get an F wrap back.
So
and you're returning an A, and an A's got a mul.
Yeah, I'm returning an A. He has a mul. Yeah.
Like you promised that you were going to return the type that was at the top.
Yes. Yes.
So it has to have the mul because that was the promise you made, was that A and A are going to be the same type.
Like if I took this E thing out of the middle and just like hid it from you for a minute, what you can see is it's the same structure as what I had before. I have to have an A, and the A have to have a mul, and the mul returns an A.
Yeah, that makes sense. But you're explicitly wrapping an F wrap, so obviously it's going to have the type of F wrap.
It has
like the output.
The deal is it has a cloned version of F wrap, if you will. There is no requirement that
So this example, your F wrap only has those two fields. If you also had a mux field, but you didn't use it in this expression, would it show up here as well?
Because it is produced. So if I come up here and I say mux is equal to, I don't care what. Okay, and now my comment will say F and mul and mux And down here in this guy, I'm going to get a mux. And when I come on to the next guy, for the same exact reason, I'm going to get a mux.
So that B type that's nearly the same type will have the mux as well?
Yes. They all get the mux because they are.
Then why doesn't it just give you A?
Because it's because the mul that's the innermost one is not constructed. It is passed in.
Oh,
Because it is passed in, it can have unrelated fields, no mul, no mux, but a baz and a bar and a boop. And what that means is all the wrap layers are all in fact instances of the A and F wrap, except the innermost mul, which has been passed in, has no constraint that it be an F wrap type. So it just has junky extra fields.
Okay, so if I wanted to display this as the innermost type is just whatever type it is. The first wrapping is innermost type _1. The second wrapping is inner type name _2, 3, 4.
Yeah.
And I just decide to name all of the layers.
Yes. So
Would it be
here's-
reasonable for me to print this type as, here is the innermost type, here is the type with a _1,
I'm going
dot, here is the type _n, and just declare what that n is for how many deep it
right.
went.
What? I'm going to restructure this a little bit.
I'm trying to figure out if I can, like, by putting an n somewhere in the description of
Yeah,
this type, collapse
don't have
the
any-
description size.
way to know that I've got in the standard Hindley-Milner algorithm types here.
so in Clojure world, they've been somebody's been wrestling with similar, I think, problem
Yeah.
in their spec library. I don't know if you ever looked at it. It's not a Hindley-Milner thing, but they have spec alpha, and then they have spec 2 alpha, which has been this extended work in progress for a long time. But one of the ideas that they have in there is that you can take a kind of type and say, select which part of it I care about. So like, I have A, but only this part of it. Right. So in that case, you could, instead of doing this generated type, you could have the F part of A is all that's required here, rather than having this new type, which has F. Does that make sense?
I'm missing what happened to mul here.
So basically you have this idea that I can take a subset of a type. It's not really, it's a bit different than typing. They're not, but anyway, it's
I mean, we're talking like this is a programmer assistance to derive the correct type you wish the system had derived by like Haskell's F wrap.
Yeah, like I don't know if this would work. I don't know if you could derive it, but it's just an idea and it would get rid of this sort of type that you're generating as a new type that's anonymous from A. You can see that it's related to A, but it doesn't really show it. It doesn't really have that information. And so you could actually kind of preserve that by saying, I want to have a type which is a subset type. So it's like, it's the subset of A that's only the F field.
Okay.
So then the type of
that's what I have here.
Yeah, you would have A, like subset A with only F. I don't know how you'd express that, but
Okay. Like I
Is
know
that ... syntax for us, or do you expect AA to understand that?
Well, the ... is AA saying something. Oh, geez, Arthur showed up. Didn't see him show up here. Hey, Arthur, sorry about being slow. We're in the middle of deep type theory things.
Yeah, no problem. Hi, everyone.
My only comment to this is, I don't know is significant or not, but the first is like a record definition here.
Yeah,
The Haskell is like a class or a type definition. It's not constructed from the values inline as it would a record be. I don't know if this is significant or not, because here is not expressed as a type. You just define it in line as a record, and Hilly-Milner has to figure out the type.
this FWrap is Haskell is, as far as I know, is a data type.
Yeah, but it's declared as a type. You don't
Yeah.
declare it as a record.
I've declared it. Well, I can. Oh, I see what you're saying. Yeah, I'm
I don't.
not a Haskell expert.
I still don't know if this is significant, but it's just crossed my mind because
Write the Haskell type declaration, because I don't know enough Haskell to write one.
yeah,
I mean,
this is the data type. It's like a class definition with a recursive type inside it. But the AA, as we are mentioning it, is like a record definition from the values. It's not a class definition with some fields, as I understand it.
I don't understand the difference between Haskell class and an AA class or an AA.
And the AA, if you define a record, you define it as a record from A equals to B equals some string, yeah. And
That's what we
the
call structural typing, yes?
the
What
Hilly-Milner,
what I'm hearing is what I wrote in Haskell was a data class definition.
yeah,
And what Theodore would like is a type definition, like a type def in C++.
you can define. I believe this data type defines the type. It doesn't define it through the values.
Okay, right. It defines it because I gave it to you on the spot.
Mm.
Right there, I mentioned all the types directly. So there's no
So-
influence here. This is just a list of types.
I'm not sure the point that I was trying to make here, but from my perspective, neither Haskell nor AA are allowing you to dictate sort of the layout in memory of any of this stuff. We're talking about an abstract type that involves, a float and, this mul function and maybe some other stuff. But we're not saying where any of these pieces are or how
Okay.
many of them actually live in an execution path.
Right. So for me, that piece comes later in the sense that I'll give you a hard, strong guarantee of layout. But I'm not talking about layout right now. So I can give you the layout for this. And in particular, final
Yeah, so
assignment.
but the wrap function doesn't care about the layout. It'll apply to something no matter what the layout, as long as it's got an F.
Yeah.
As long as it's got something that, that we can put in that F field.
So if I go look up here to FWrap and I see it has mul, which means the y.f field, what's the layout of that F field versus the F field I got from the structure I defined right here? And there's no reason those two layouts have to be the same. As
Yeah,
far
this
as
is-
I'm concerned, that's part of the I'm gonna say the optimizer doing layout games comes a
Right.
little later.
Yeah, so this is a type, nothing to do with the layout.
That's correct. But there is a constraint that you pick up from here that says, if I have an F field and a Y, and I have an F field and the struct I just made, and I'm putting them into the same code, those F fields have to have the same layout. Or I need a different instance of the mul field with different F layouts according to what Y looks like. So this may not let me have a straightforward, so easy to understand execution path, layout, the definition or whatever, the actual
Are you
implementation
saying you might need virtual functions?
to go get the F field. So here I have one field F from Y, which is an unrelated type, and what FWrap produces, which he passes back into himself. So if you throw all those constraints together in a constraint graph, you pretty quickly solve that the two Fs want to be in the same offset, wherever that offset is, from the start of the structure. Pass the structure pointer, grab the same offset. Now the multiply function just grabs the offset, loads and multiplies and goes. It's all good. As soon as I have other fields and I'm passing them around with multiple different things for Y's, have other unrelated types, the F fields start to fight with other field layouts, and they don't all necessarily get I can derive a case where it is not possible to have a fixed layout what honors all the fixed uses with all the functions that are using all the layouts. So that in order to get the F field, I might need different versions of mul, for instance. Mul might need to be a virtual call because the offset is not at offset plus 16 because I had something else that has to be plus 16.
Yeah, well, this is just a consequence, I think, of the fact that FWrap is generic, right?
Yeah.
And so depending
Yeah.
on its use, the layout of the functions that it offers may be different.
Right. So there's an argument made here that I've given myself enough rope that I've hung myself, and then I need to take that FWrap notion. So I didn't bring up row polymorphism, but what you just said brings it right up as a case in point. If I bring in row polymorphism, I can claim that the FWrap I'm producing is equal to some other type that is the same type as what Y is. But I don't know what that type is. It can have extra fields, and that F field might mean different places because I have a version of integers that I want to have, for instance, metrics on them. So I know they're meters or gallons or yards or whatever the hell. So there's extra fields floating around. But I only take yards to yards. I only take gallons to gallons. And then whether the F field aligns and the gallons guys or the yards guys, I don't care because the mole for gallons and the mole for yards are different and they can pick an offset, whatever the hell it is. So there's another version of FWrap, which is more constrained that both admits to having a single offset for the Y.F field and prevents the infinite explosion. And maybe I can do inferencing on as well. And that's row polymorphism, which I've not brought up here. And my voice is going.
So anyway, I think you're back to your original question. Do you want these things to be,
No, I think I've answered
more or less generic?
I think you've answered it for me. I want to be able to write the current FWrap and I will live that its type sucks. I want to write a version of FWrap which will make a concise type and it will take an FWrap and return an FWrap. And maybe you have to say FWrap to make that happen. And maybe I can do something where there's a little more help from the user. But I think as soon as I say help from the user, I might as well just say, you gave me an FWrap type and I'm done.
So I would argue that you ought to give the user the ability to provide that extra help,
Yeah.
the label or whatever it was you want to call it.
Yeah. I am.
Don't force them to do it.
Right. I am. The code down below the line here is that case. Here the user has decided I'm going to define FWrap type. Then FWrap just mentions FWrap itself in a few places internally. As the core piece, the main AA has a little different syntax, but it's pretty close.
It almost feels like you could hide that piece of advice inside the linked tool. Hey, I noticed you did this thing that's going to give you a kind of nasty type. Have you considered doing this other thing that's going to make this type nicer?
It could be. Yeah, it could be. Like the FWrap is given because Y.F is not related to the struct that produces result.F. The two .Fs don't have to align. So if I pass one for the other, mul sees .Fs from different places. So now mul has to, Cameron was saying, hey, you're gonna be virtual on .F. Well, I can play a game where maybe I get rid of the virtuals on .Fs. And I probably will hard guarantee you that I'll make that game happen, but then the virtual might move to the mul field in the FWrap code.
Yeah, because you can build an arbitrarily complex set of problems that there's no one solution for.
That's correct. Yeah.
And there's some developers talented at doing that. I've worked with some of them.
Yes, well, I don't need any help making them myself, that's for sure.
Right, but the goal was not avoiding all virtual calls.
No. Right, the goal for me was actually just come up with the fucking type and decide that I believed it. And now I believe my type. Y'all have convinced me my type is correct and ugly. And there's a better type out there to be had, and I should make sure I can get to the better type.
I believe your type, but I am not convinced that it has to be ugly. I suspect there might be a nicer way to write it down.
Yeah, you're trying to say
by auto-generating some of the intermediate
bring out
names.
a regex, and we can get rid of the redundancy. I'm going to rename A and B, and this type here, I'm going to rename A and B. Okay, Now this is in fact textually identical to this one. They're just perfectly down the line identical. Fine. And here's a B. If I go take my constant multiplies and go another layer, I'll just add another C, which is just like a quick math.
Yeah. My only difference being I kind of wanted to name them
Yeah.
inner, inner one, inner two, inner three.
Right. So I can do a little.
Or in this case, since the inner one is named A underscore one, A underscore two.
Right. So, you know, I could go.
If you have a bunch of methods in a function, aren't you going to end up with a combinational kind of explosion of slight variations on these types?
No, because they all get all of the functions. So you just get the one type that's got them all.
Like you have A and say you've got a bunch of functions like mul, and then you're using them in different ways. And gradually you get an A with, you get a B, you get a,
Well,
you get
because
something
I'm
like
constructing the type, I get this type with all its extra, not just mul, but mux and baz and bar and div and add and sub and all that shit, right? Okay. When I come down here, C will have baz bar. Whoops, I didn't do what I wanted. C will have baz bar bucks, add, subtract, multiply, divide. B will have it as well. C will have it as A will have it as well. They'll all have them all. You're correct. They won't be, you know, twisty maze of slightly different. They'll all be identical, except they'll all refer to the prior dude in the line. And that's a good test case for me to go produce and make sure I'm not like wrong. You could be right. There's,
you do something like what you did with mux, then you're gonna get a bunch of types. And then if you do something with baz, then you're gonna get a bunch of types. And if you do something with both of them, then you're gonna get another bunch of types.
I'm not getting types that are variant by baz, bucks, mul, add, subtract, multiply, divide. I'm getting them varying by the depth of the expression. And they all have baz, bucks, multiply.
Right.
So, and I would have to confirm this. So this is my belief. These are test cases. I can
So are these effectively something like subclasses?
More like prototypes. But yes.
Derek, is your point kind of your question, if you will, that when one of these types that can go, you know, to have multiple of one of them gets used somewhere in the right side of an expression, and then the left side is similar to the thing that's showing up in the right side, that you get an exponential effect? Is that your concern?
It is also a concern for me that although I believe that the types I get are no bigger than the size of the program, I'm not actually going exponential. Understand that under the hood, there's a lot of sharing going on here. So I do get these unrolled in this case, but if I start saying add, subtract, multiply, divide goes to the int and the float version, and each of them has their own buddies going down the road, whatever, all those inner guys, they all start sharing. So the types go deep, but they don't grow large.
Yeah,
It's
which is why I keep reaching for, is there some way to write this as induction?
Yes, right. Yeah, I understand.
I mean, I think the type is right. The only thing that's bugging me is I'm not sure what the right way to write the type down is.
Yeah, I want to put the multiply in a function like a factorial and confirm that my algorithm terminates without expanding indefinitely. And then my belief is that when it terminates, it will wrap it in a pretty straightforward, simple type, and we're done. And that will be good enough for me for now. And I'll have some, you know, some expansion on the leaves of things that I don't care about. And as long as your loops actually terminate with a, you know, cyclic type, I'm just going to walk away and declare.
Sounds like Aaron wants you to turn a pile of text into a macro.
Yeah, I'm trying to not do that. These are like types, right? Sometime later, 42. I understand the 42. If you keep unrolling it, it gets deeper. Yeah, right. Also, if I do, you know, FWrap is named by the user. So, you know, as Keith's pointing out, you just name it, and it all just says FWrap, and there ain't no expansion at all. And that's actually the answer I'd rather have. So that's sort of And I
Yeah.
think row
I think
polymorphism.
part of the challenge that you have, Cliff, is that you're too precise in one place, which is the kernel of the recursion
Yeah, right.
is I'm not really good with type
No,
systems.
I would much rather the argument to Mull
Yeah, you want to approximate the finite depth as infinite depth.
is FRAP, right? I want the thing that says I'm a ... struct. I want it to be an FRAP, where the ... only contains the FRAP things. As soon as I do that, everything rolls up tight. It doesn't expand indefinitely. They're all the same thing. It's boom, done.
You require your user to type the recursive expression. If you
In
name
this
it,
example, to avoid the unroll according to the size of the expression, I need a
Mhm.
user to tell me to throw away some type of information on the innermost. Then
Mm.
everyone else becomes unroll layers of the first guy, and I can re-roll for you and peel that up.
Mhm.
So I guess for me, that boils down to the question of whether you can automate that sort of throwaway thing without throwing away anything useful. So is the name FRAP more restrictive than the pattern of the definition of FRAP, I guess is.
Oh, yeah,
What I was
certainly.
saying.
I'm asking the user to throw away some information. How does he specify what he throws away? A way to do that is.
No, but is it actually throwing anything away? What gets thrown away?
Throws away.
Like how is,
It's this expression.
like in this example,
This argument to Mull takes any number of fields. If you look at execution of FRAP of 1.2, I get a thing back which has a Mull field. If I then take that con12 and I say dot Mull and replace con12 here, I'm going to replace your replace that. Well, I won't highlight one with another struct, which is f equals 2.3 and baz equals quote ABC, right?
Right.
okay, yeah.
It
all
maybe
right.
you could call this duck typing.
I am strongly duck typed. Yes, it's strong typing, but it's duck typing.
Yeah.
That's what the ... allows me to do here.
But here, back up a minute.
And even saying that you want say a subset of FRAP with only F is not the same. Like unless that's just another way of saying that it's a.
No, if FRAP is a
version of
nominative
something, that would
name,
mean something
say
else.
FRAP, you only allowed FRAPs in below as a subclass.
So it's much more restrictive if you say it's FRAP. This one you've got, you can give it anything with an F.
And I think I'm hearing Dan, maybe I'm missed who was saying it. Say, what if FRAP wasn't nominative, was just a structural name? Then I'm throwing away the ... and demanding the Mull as a recursive thing, but I'm not saying you can't have anything else. That doesn't help me here though. Go back to my example here, because having Mull does help. So this is row polymorphism. So what you guys are suggesting is the solution here, I think, is row polymorphism, which I've been reading about all week long, and I think I know what the hell to do with. I don't have an example here, but it would be here. I'll show you the example of row polymorphism. It's kind of like a crazy thing. You make a new variable that's got all the other labels, and it's an actual thing that you're going to pass along. And maybe I'll pass it here in FRAP and say y dot which I can just do with a y here. And so I'm going to do it that way here. So multiply comes in, y comes in. Also, I take in other stuff up here, and then down here, I'm going to say other stuff dot extra labels.
You don't have any kind of splat operator to say, and I'm also passing in the contents of this struct, right?
Yeah, this is the splat operator. This is a type called row polymorphism. It is a type safe way to do the splat operator. Exactly, I'm doing the splat operator. You could argue my syntax sucks because I made it up on the spot. But it's the splat operator. Every other field. So now FWrap takes a float and it takes some other structure and he produces a thing, which is that other structure. And he takes that other structure. So FWrap becomes, the lowercase FWrap function becomes an anonymized version that takes anything that has a float field, a mul field, and a bunch of other fields, which he'll just pass along when you make them. So when he makes a new guy, he'll pass along all those other fields. Now there's an optimization and performance. Can this be made to work well, efficiently, blah, blah, blah. It's a separate question. Semantically, typing wise, you know, that's what I'm trying to express here.
Yeah, but
It does make it slightly more obvious that you're carrying around all the extra fields.
Yes.
so what I was thinking is that, you know, you say you've got a named type FWrap and it's closed with just F and mul. You could create you could have a sort of function or something which says, I want subset of FWrap
Okay.
with
Just
F.
said subtyping.
No, not a subtype.
Okay. Okay.
So I want to select a subset of the fields in FWrap.
Okay.
And it becomes a structural thing, kind of like what you see here.
When I select a subset of fields, I don't have an FWrap because I'm missing.
Yeah, so I'm the anonymous hedgehog, so I just highlight this thing here.
Yeah.
And so it becomes that, but you could basically ask for it by name, and I could say FWrap subset, I just want F. And now it becomes a named thing, which is subset of FWrap, which is F. It would behave like this. So it doesn't have to be an FWrap. It's just something that matches this part of FWrap.
That doesn't help my types, I don't think, because I still have to have the subsetted guy is the innermost. He's different from the outermost guys, which are made according to the struct that's in the lowercase FWrap function. Mul is clearly taking a subset of what FWrap otherwise produces. So maybe it helps if I name this here. Here is a struct. I'm going to give it a name only for convenience. Maybe I should give you a QWrap so we don't get confused on our things. That's the name for that function, for that struct. What I get down here where you've highlighted, I don't get a QWrap. I get something else.
Yeah, but wouldn't it be helpful to say that this is a subset of QWrap, so it's just the F part of QWrap?
Yeah, but it doesn't solve my problem. If I say it's a subset, then I come down to the wrapping where, you know, Aaron's busy trying to solve me, where I say A has the subset in its mul, but B has a full FWrap or full QWrap, and he takes A.
If you type mul and it's ever a subset, isn't it always a subset? Can't you then just say that, oh, actually, this is always going to be a subset?
No, because I've typed it according to, unless the user wrote an annotation, there is no constraint on FWrap or mul's argument. So here's the user wrote a constraint is what, you know, what Haskell says, go do this, and it works.
The constraint is that you just need F, right?
No, the constraint is that I don't use the ... There is no ... That's my problem. When you say I just take an F, if I also drop the ... I'm solved. Okay, having been solved, I don't care about the other piece of it. I'm solved already without it's the ... that's causing me to error.
But if you just took an F, then you couldn't even give it an FWrap because it's got other stuff in it, right?
So it is the case in this type just highlighted that I only need the F. I don't need the other stuff.
Right, but if you don't have the ... isn't it restrictive that you can't have the other stuff?
Yes. If I got rid of the ... on the type, I would not be able to pass other stuff. this would still make this type different from the other moles.
Yeah,
So my mole would lie on what it takes when I wrap it the next layer out. This generated one for just calling FWrap says I got a mole whose Y just takes F. But this one where I call FWrap would suddenly say, no, there's no mole. You can't call mole on the result. And then this
Yeah.
code here would not be allowed. The con 1-2 mole, that would not be allowed. Because con 1-2 would not have a mole.
Why specify syntax for open rather than syntax for close?
The absence of the ... is what I'm using. I'm getting rid of my row polymorphism because it's.
Yeah, I get that you're using syntax for open and no syntax, meaning closed.
Yes.
But you just as easily could have gone the other way. How did you decide? ...
looked like, and the rest of the stuff.
I see. Because you had convenient syntax lying around.
Yeah, because, well, the English language understands ... as and all the rest. So if you look at the papers that I've been reading here from the 80s and 90s, when they're wrestling with how they figure these things out, they often have a plus and a minus kind of variation. They say a field is available or a field is required or could be available and required. And they track 2 bits per field. And then that comes up in the typing. And in the end, they can tell you they have some available fields that no one uses and they don't do anything with them, but they know that. And they have a required field that no one makes available, and that's going to be a type error, and you're done. They don't try to do type error games like I'm doing, fine. Or it's available and required, but they definitely carry 2 bits per field. I just said I don't need to do that because if you're available, then you're there. And if you're required and not available, I'll make you available in an error. But if you're required, and you know that you're not an available guy. So I needed 1 bit, which is the ... instead of 2 bits. And I need 1 bit for the whole structure and not a bit, 2 bits per field. So it just simplified the presentation a little bit.
And hopefully the mental model with it.
Well, that was my theory as well. More people with power on. Oh, yes, I'm right in the middle of the smaller area without power still. Man. Fine.
So,
Get my generator still pounding away. Fine.
so I mean, I haven't offered my opinion yet, which is that the problem is that you're trying to do type inference. If you don't do type inference and you only have type annotations, there's no problem.
I think you're 100% correct, sir. If I start doing this annoying type inferencing, we'd all be good.
So, I mean, so I'm trying to figure out in my language how to not do type inference.
Well, there
And
you go. Pretty much you have to do it on a small scale. Within
Well-
expressions, everyone expects type inference.
Well, no, because like you have Python or whatever, and like it doesn't do any type inference. It knows the types of the expressions, and it just applies whatever method is correct for the runtime type.
Okay, if I do 1 plus 2 times 3, 1 plus 2.1, the 1 is an integer, the 2.1 is a float. What's the plus operator?
Well, okay, so sorry, I said Python.
We'll know when we're
Right.
running.
Python does an effective flow typing by just typing as the program runs. Like,
Well, that would
Yeah.
be Python.
what's the
yeah.
best flow typing? The actual flow at runtime of
Yeah.
the
Deferred-
program.
It's called deferred flow typing.
Yes.
It's
Thank you.
brilliant.
And Python is 10 times slower than Java. So thank you very much.
No, the compiler's fast.
What do you mean? No.
Granted,
the
Max is
size
not here,
will
so
the
I
move.
have to say that languages aren't slow, implementations are slow.
All implementations of Python are slow without
No,
fail.
Python is actually pretty fast.
No. They bail out from Python, go to C in some cases, or they take a subset of Python that they can make strong typing out of, and then they compile that. But it is not full Python because PyPy is not the next generation Pascal implementation that's 10 times faster. PyPy is PyPy because they stay up front. Oh, we can't handle the following stupid things Python does. And lo and behold, there you go.
Well, I mean, I'm not saying that I'm designing a dynamic language. Like that's not in the advertising.
Okay,
What I'm saying is that it has a dynamic semantics so that I don't have to use type inference to figure out the types of the things.
all right.
Basically, I'm saying it's type free. I don't have to worry about static type inference.
Well,
controlling the-
sounds like JavaScript. There's
Yeah.
there's a speed game to be had if you have types.
I will say,
Well-
Cliff, when you first started this project and you were all like, I need a high level language that's also my low level language where I can get speed.
Yeah,
I was a little bit skeptical of that because
Yeah.
JavaScript and Python have done so well with the like, I have two languages, one for the performance piece and one for the business logic piece.
Oh, I see.
But
Okay.
when I first ran across the, hey, let's try and run some of our services on ARM. And we moved a bunch of the Scala code to ARM and it just ran. And then we tried to port Node and Python stuff to ARM and it was like, oh, drat, where's the Fortran compiler? And it was like, oh my God, there's actually real power in this is in one language and I don't have to switch to an entire different language and figure out how to do all the tooling to get everything to work together because I actually had a hot loop somewhere.
Java run once, write anywhere. It actually works. That was the goal and it worked. So we made good code for ARM. We made good code for x86. Yeah. And Python
Yeah,
says
that
give
JVM
up.
stuff's really paying off for us in 2022.
Yes, it still works. Fine.
So, I mean, I'm not getting rid of type annotations. So if you want your code to go fast, you just write the type annotation.
Oh,
The thing is that like, you don't have, it doesn't do inference. So
Yeah.
like, if you get this question of like, should I unroll my type 10 times? Or should I just write the recursive type that's nice and simple?
yeah.
You know, the answer is the user chooses. If they want, you know, if they want the simple recursive type, that's what they'll use. And if they're doing some weird, you know, row polymorphism record thing where they want to use random fields stuck in their type, then they have to write a complex, long, annoying type.
Well, fine.
But that puts a burden on the language, on the user to
Then your
write.
language becomes esoteric.
Mm.
Well, if you have to write complicated esoteric types, life gets weird or it gets difficult. I don't know. I've looked at some of these other languages where type annotations got complicated and it becomes hard to read.
Yeah, that's correct.
Somebody uses it and then you have to use their stuff.
Right.
Right.
What I'd say, Alan, by the way, is that opinionated languages sound bad, but opinionated is actually not always a bad thing.
Yeah. You get
Well,
a
yes,
consistent.
they have to have opinions. And if your opinion is that inferred types are prettier than types written out by a user by hand, then you're wrong.
Yeah, but also that inferred types can be so complicated. There are a lot of cases that the Haskell code, it's simple when you look at it, but you have to figure out the types and then you are in trouble, or real trouble. You have to share the code days to figure out the intricates of the types instead of if all written explicitly.
What I ended up doing in Elm when I had, compiler errors I couldn't understand because of typing was I started adding annotations. And as I added annotations in places where I thought I knew what the type was, and I didn't want to bother with annotation because I was writing fast and free.
So you
kept narrowing where the type error was until it popped up as an obvious thing.
So you need a thing that you try to get rid of it?
No, I'm not trying to get rid of type annotations. I'm trying to say that I don't need them, but they're great documentation. People should write type annotations, no problem. I want to know what it means to type without an annotation in case they didn't. So there's a difference between a required annotation in order to get the function to compile at all versus what I'm doing here, where I'm just saying, yeah, if you don't want to write an annotation and you got the code right, you're done. You wrote it and you walked away and life was good.
So the easiest thing is here, if you encounter a recursive variable, you just type it. The user should type it, and you won't deal with it.
What'll happen is I'll type it internally, and I'll get a valid type that you hate, but you don't have to see it because you're not looking at it unless you make a mistake somewhere.
Yeah, but look at here. You have to manually unroll the type once to Hindley Miller figure out that is recursive type.
No,
You can
no,
just
that is computed internally in the typing system and I just use it to validate your program has no type error.
okay here up here. It's
Right,
not
that
a,
has no types.
yeah, but you have to manually unwrap it here because you have to
Well, that's
and
because
then
you'd have to unwrap that in Scala or Elm or Haskell or anything else.
mm,
Or C code. I can write this code in C code.
of course.
And it
Yeah.
doesn't the unwrap part is because exactly what I'm doing is I'm writing a fucking monad. I'm writing a wrapped float that mimics being a float by having operators all throughout it, so I can do operator lookup via field lookup instead of having operator syntax. There's other reasons I'm going there, but the game we played at this point is I'm just wrapping my primitives and putting all the functions, including operator precedence and lookup overload and shit, as fields in the wrap so that I can do field lookup games as opposed to doing operator precedence lookup games.
I will say this whole discussion is making me imagine IntelliJ with a little squiggly line where you right click it and it's like
Yeah.
auto fix, roll up this type so that it's a recursive type. It doesn't look ugly. And then you do
Yeah.
that and it underlines it with a little squiggly line and says, make this type more specific by unrolling the type.
Right. Yeah,
It
right.
gets mad at you no matter which way you wrote it.
No, don't do
Yeah.
that. Pick one and say it should be wrapped, but I want the user to tell me what the right wrapping is. And the obvious one is give a name for the struct. Then
So-
mul
So-
takes that field of that name.
So you're gonna introduce Clippy?
Yeah, no, I'm going to introduce typing in no, I'm going to use IntelliJ wrappers at some point.
Mm.
So
Oh, yeah.
I have a question. What do you think is the most bang for the buck subset of typing to include to get, performance without sort of spending a lot of time?
It all depends on whether you want to have Henley Milner style type inferencing for lambda expressions or not. If you skip lambda expressions or you don't, or you demand typing on all your lambdas, Java has lambdas that you mostly infer on. As soon as you say, I'm going to do inference on lambdas, you need Henry Milner, that's your easiest one. As soon as you say, I'm only going to take annotations on every function has to annotate, like C has it, every function is annotated, it's return, its arguments. Java, every function return arguments, not lambdas, but other functions. As soon as you do that, you can do forward flow typing, and you don't need Henry Milner. The standard forward flow typing that you get out of a C compiler. That's sort of the easiest one. So those two pieces cover these two different realms, and I'm here because I was trying to bridge that gap.
At the risk of sounding like a lazy programmer, I think the biggest win of all the type inference is I type a variable name, hit a period, and get suggestions as to what are the actual fields that exist on the thing.
Yeah, yeah.
Which doesn't sound like it should be important, but
It is.
Yeah. And actually, stupidly, Emacs from 40 years ago does a really nice pattern match job when you do that. It has nothing to do with types, but it's right more often than IntelliJ does. Routinely, fucking IntelliJ whips out shit from like packages I've never seen before in my life, and goddamn org.apache.commons.whatever things that I've never used ever. And I'm like, why are you trying to suggest this thing? Whereas in
I
Emacs,
thought Emacs was a dumb dictionary. You typed a period. Here's every string I've ever seen on the left side of a period and everything I've ever seen on the right side of the period.
There
And
are
that
a
was on
lot
the
of
left.
packages that do better than that in Emacs now.
Right. Yes, and it does better than that. The whatever I'm using does much better than that. It's not typing all the way, but it's definitely smarter than that. And I get the right answer way more often than IntelliJ does.
Because that still counts as not a structure, but a nominal searching for the dot operator.
You talk about the lookup that Emacs is doing, or
Yeah, the lookups of the Emacs, because
doing
it's
something with pattern matching and enough smarts to know that I'm inside of a function, I'm inside of a struct, I'm inside of a whatever.
Yeah.
Trims it big time. And then his first suggestion is, what fields have you used recently in this particular context? And I'm usually one of those, and it's done. Fine, never mind.
Yeah.
All right. Hey Dan, nice talking to you. Yeah. Well, I think I got what I wanted. I think I'm going to live with my types and go stare at row polymorphism or not as the way to bring up the missing pieces that other people said, hey, this is stupid because, and I think I can get them out of row polymorphism. And then I'm going to be done with typing, and everyone's laughing at me because I've said that for a year.
I have a syntax question.
Yeah.
So if I have a struct and it's got some extra fields in it and I don't know what those are necessarily,
Well, you don't have
is there a
struct.
distinction between my saying, oh, it's got an A and a B and ... versus A and B ... rest? And is there a way to say, hey, take all the rest of the things that are there and just like stuff them in this struct so that I can access them as a struct?
That's row polymorphism.
So you can give a name to the stuff that's in the ...
That's
I
what
can't say ... name.
exactly what row polymorphism does. It gives a name to the ... It's not a label and a type for label and struct. It's a set of labels and types. And you don't get to pick apart and tease what's inside of it because it's a polymorphic type variable. It gets set by according to which uses for passed in or whatever. But that ... gets a name on it. And I can make a new struct which has the ... of some other struct to get all those extra fields that I'm missing.
Yeah. But yeah, certainly you can bind the variable to the ... So
Yeah, you bind a type variable to the ... Bind a variable to the ...
So and you can include it. This certainly can be useful, but as well as the minute as you try to refer to something inside the ... it's the structural typing all the way all again. You can't pick. Yeah.
It's the splat operator from Python. You can't look inside of it, but you can copy the all in mass. So if I knew, for instance, that my frap had a y.f, but it had extra fields and I didn't know what they were, that was what I was doing with my wrapping. Exactly what I was doing with the row polymorphism with the other thing. Suppose frap takes basically a float he's going to add in and also something which describes all the other fields that I want to see besides the f field. You have to have the f type float, but you're going to have as many other fields as you want. So I'm going to call that other things. And then when I make my struct, it's going to have f and mul and all the other fields. So I do a row polymorphism thing where I say ... other or other ... or whatever you're going to do there. And that is some special syntax that says splat expand the ...
So where are you selected the what?
Oh,
instead b equals to. Oh, okay. Because the next has the
I have to pass in the other. So frap takes another, it gets passed an extra other, and here I need to define an extra guy, and all the things that get in and out of frap will be of this kind that I'm writing right here, whereas an f is some value and what other field is. And I'm a mul because I demanded it, which I'm not filling in, and it might have something else. It has a metric equals, gallon. And now frap takes gallon things and produces gallon things, and gallons understand multiplies, and they have a number like 2.3. And that's what row polymorphism is for. And that's probably what comes after I do this. So I'll sort this out and I'll finish my testing on overloads, but I think my overloads are done. I think they're working. And I'll just say this types are in fact correct. I don't like them and they're correct. And then if I want to write and the other thing the core AA will need is a type name syntax, which I don't have, already got pushed down below. Yeah, the main AA has a type name syntax and core AA does not. So I'll have to go sort that out. Where core AA is supposed to be just like the pure lambda calculus. So you're not naming types, they're all inferred. Here, if I name a type, I'll have to figure out syntax to use it. And the only reason I'm naming it is so I can have a cycle in it. So not a nominative name. Main AA wants nominative names. Core AA, I don't think wants nominative names. I hope I don't have to have it 2 different types. All right. I'm done with this. I want to go let Simon have a turn.
Mhm.
Where the hell is Simon's go?
Probably let's just do it next time, I think. But
Done. Why? You want to be done? People want to go? It's 11:30. Here's what you're talking about. Tag unions. Yeah, tag unions are interesting.
Why not?
You want to let it go till next time? I think tag unions are fun, but it's fine.
yeah, I don't want to push the meeting for like another
All right.
half
Well,
hour or
well,
something.
Aaron got kicked out again. The issue now for me is I'm going to Burning Man, so I'm off for 2 weeks.
Yeah, I mean, I'd like to discuss unions before.
Yeah. So I believe
All
it's
right.
Simon, go ahead,
All right.
because in 2 weeks we'll forget.
All right. So this is a bit of a follow-up to the thoughts on enums I had a while ago. And after some of our discussion, I thought how the different approaches fit together, and I made this table where basically you have 2 dimensions, one for whether you wrap your values syntactically when you're creating some enum value, and the other dimension is whether at runtime you have some discriminator that allows you to tell to which value discriminator belongs.
Right.
And basically the orange one here is like we have like the no syntactic wrapping and no runtime tagging, which is usually like what we call a union type. You have this type pet, and you can have like a cat and a dog, and if you do another cat there, it's equivalent to cat and dog, because you have no runtime or no bit or no discriminator to tell them apart whether it's the first or the third cat. And the other well-known thing is the green one, which is like the traditional tag union, ADT, enum, whatever you call it, where you have like an enum definition, and then you put in the definition of your enum members, everything as expected. And I was wondering some time ago, okay, can I have the runtime tagging of the tag union approach, but without this syntactic wrapping? And I came up with this syntax a while ago, and with the during the discussion, I think Cameron had the very good observation that that writing it this way makes it look like cat and dog are definitions on their own.
You guys are sharing my screen. I'm trying to
and
I was about to.
and
yeah, sorry. Elm is the obvious thing here. Fine, they have a different syntax. You should go look at Elm syntax as an alternative. But keep going.
And the observation was that this looked like cat and dog were like basically their own definitions. But my thought, one of my goals was to say, okay, I can do enums of arbitrary types, just like with the union types above. So I can say, okay, I have an enum pet, and I can point to two pre-existing types. For instance, in this example, I have like a cat and a dog defined somewhere, and I refer to them. And I think Cameron brought up that the syntax was quite confusing, and I kind of realized that if you're not doing it like this, which has the wrong intuition for many people, we could do it like this, where we use syntax like this, which feels a bit like for interfaces, where you say implements A and B, and you know, okay, A and B are not defined,
Mhm.
where I'm implementing class X, but they refer to existing ones. And I think with this approach, the idea becomes a bit more intuitive. So that's the approach where I arrived, saying, okay, let's try this syntax here, and will be interesting whether it works out this way or not.
I'm going to make you the share host and go hunt down Elm's alternative syntax.
Simon, is this
Yeah.
because you're trying to explicitly because you're trying to do tagged unions? Is that the basis?
Sorry, can you repeat the first?
So the examples you're giving, you kind of have a goal driving this, which is that you want the type itself to be a tagged union explicitly, right?
Yeah, because I don't really like the semantics of union types, where you pipe things together, like this is a cat or a dog or a cat and a dog, and your union might just lose some elements because they are determined to be identical. So yeah, I want it to be tagged, and I want to be able to refer to arbitrary existing types as members of my enum, so to say.
And
Right.
is
It's
it
almost
one
like
of
sorry,
Go ahead.
go ahead, Eric. Sorry.
I was just going to ask if it's one of your goals that it be sealed, like you wrote in the JVM example, that it's a sealed interface and it only permits cat and dog. Is that like a goal that it can't ever be extended? Like if someone's using your types, like uses, like someone gets a hedgehog, then can they add that?
No. So basically, yeah, everything, if I write class, it's
Simon,
always
you can
it's
share. You can
it's
share your screen.
always implied that it's final. Shall I try to share? Not sure whether it works.
Yeah.
Give me a second.
When I'm coding, I always like to keep things open, and then whenever I declare something, I extend whatever I'm trying to extend right on the spot. So the way I would want a syntax like this, maybe I'm thinking of totally different goals, is I would want to say, class, I declare cat, and then right afterwards I say cat is a pet, but then I could say cat is an animal as well. Like it's not like this, it's not like inheritance, it's still more like your enum or union type thing. But I want to, wherever I declare something, I'm going to say this is one of those.
Yeah, I'm. Oh no, it's all gone.
Hang on. Somebody wiped out, and I was trying to do. Oh, I see what happened. All right, that was my bad. Sorry, I was trying to format some little bit of code and I blew it.
Yeah, I think the whether we can nest these enums or have type or class hierarchies. I'm not really sure. So from
I'm not talking about class hierarchies personally. Like what I'm just saying is the same goal where if I understand your goal, where you say I have this pet concept and here's what it can be a pet, and it's sort of not changing anything about the objects that are pets, right? It's just kind of allowing them to be used together. Is that right? Like I see pets have like dog has age, cat has lives. Right, so they don't have to be the same.
Yeah.
So then I can just say like, I create another class and I say, this is also a pet. This is a pet. Or do you want it kind of closed and like, you like all in like pet definition is defined on this line of code. And that's the only, like whatever I defined when I was at that line of code is all that can ever be a pet.
Yeah, so I think I think my preference is that only the person defining pet can extend the enum. I think I know the Java approach with sealed and non-sealed, and I think the approach is also interesting, but I'm not really sure whether I spend that much language complexity. I mean, it's like in the Java case with the non-sealed subclasses of a sealed interface, where you can have more subtyping underneath. Yeah, I'm not sure. I have the feeling like the whole subclass paradigm is on its way out anyway. So my idea is to just implement this when I have time, and then figure out whether it's actually a large restriction, or whether it's something we all can live with. I mean, we could always do something like, if we want to nest things, we could do something like this. And then enum pet here, and enum. Like I imagine that approaching it from this direction could also be possible, but I have no strong opinion on that. I'd probably have to try
that wasn't really what I was thinking, but maybe
Okay.
that's interested in, but
So the intent here is, if you define a pet as a concept of these three things, am I correct? Is what we are assuming?
Yeah.
What is a pet in this case? Is a hierarchy? Is a tag union? Is a
It's a tagged union.
So the difference between type for the first example you write, and the difference between the second example is one just the tagged union and the untagged union. The first can be erased to just an integer, if I'm correct. The second has to be some kind of instance of if you don't have type information. And I'm trying to understand what would you accomplish with this definition. An enum pet is of cat, dog, and fish. Is just a more efficient way to define it, the tag union, or
Well, he wants to be able to have the classes separate from being a pet. So he wants to, if you look at the green one up above, so I don't fully understand the rationale, but he basically doesn't like the orange because it's not explicitly a tagged union. He doesn't like the green because it ties cat and dog have to be declared at the same place pet is declared.
It comes naturally because pet is encompasses all what is defined inside its scope.
Right, but what if cat is defined by one library writer and dog is defined by another, and Simon comes along and says, I'd like to create a pet enum for those two.
So the
There's
ability
more
to
than one. Most languages are designed as if every application in the world is built by exactly one person in one module. I mean, that's how Java's designed. That's how C is designed. You know,
so the goal is try to define the extendable tag union. You can add more things to it, or you can define the
composable. It's not about extendable. It's about
composable. It's a better word.
By composing things that someone else wrote, and it's a beautiful idea. I mean, I'm thumbs up on that, Simon. What I wish I understood is why the orange one is not good in your mind.
The vertical bars in
particular. Forget syntax. I don't care about syntax in this case. I want to understand the benefit of the explicit tagged union versus the thing that has all the behavior of a tagged union without explicitly being a
Well,
tag.
at some point, when you want to do something with behavior, you have to ask the question, am I looking at a cat or a dog? And given a pet, is it a cat or a dog?
Yeah,
So there's an,
but
is
in his
cat,
case, he doesn't want to know if it's a cat or a dog. He wants to know if it's a cat or a dog or the other cat.
oh, I'm
That's
sorry,
what a tag
you're talking
union
about the three-way version, as opposed to just having a tag that says cat from dog. Right, I mean, if you don't have a tagged union, you can't use anything in any precision union until you ask the tag question. To ask the tag question, you actually have a tag, it's just not carried in the structure itself, it's carried alongside in some other way.
Or who knows? It's how it's carried is not necessarily surfaced. That's
I understand that, but to ask that question, you had to ask a bit somewhere, are you yes or no?
right. A bit or whatever
Yeah,
structure.
some bit got carried along the side, that was what I was seeing is the difference between the two. One of them says, in order to do something, it's type unsafe because the bit that gets carried along is not carried with, and it can come from some unrelated thing altogether, and then I can't actually tell you that it's type safe to cast a pet to a cat.
Right, but take C++, for example. C++ uses C unions, yet
Yep.
I can look at the pointer in the union and it's a pointer to a cat or a pointer to a dog, and I can go to the first 4 bytes or 8 bytes on a 64-bit of that structure and look at that pointer, which is a pointer to the V table, and it's either a pointer to the V table for cat or a pointer to the V table for dog.
Yes, so the bits that in question are encoded in the tag itself. You got the bits for whether you're a cat or a dog in the V table.
But in the Cameron case, you explicitly manipulate the void pointer to, if I understood correctly.
That's not type safe, but I'm just saying you carried the bits alongside it. That makes a great deal of, I'm gonna say, simplicity for correctness. There is a path forward if I'm gonna use a V table, whereas if I use a standard C style untagged union, what am I looking at, a cat or dog? Somebody else has that tag bit somewhere. And I have to go
Well,
ask the tag bit.
it's a question of if the type is on the cat/dog or if the type is on the union. I think that's the difference. Is that correct, Simon?
Yeah, I think with the union time above, I mean, if you have a cat and a dog and they are both references, you can do a type check and be kind of fine.
The type check says I take the reference I have for the cat or the dog and ask it, are you a cat question?
Exactly.
It puts the tag on the cat, not on the union, because there is no thing for the union, Cameron.
Yeah, exactly. That's basically the easy case where we don't have issues. Where I'm having problems with is that if we have like if you do unions and the types are the same, I mean the cat example with 2 cats is a bit made up, but if you imagine, okay, you have a generic type definition where you say, okay, I have type X with a generic type T, and I have a union of either a string or of that type T, and then you instantiate that type union with a string, you basically end up with string. And I really, it's like, I don't like it when, depending on the instantiation of a generic type, the union type has more or fewer cases to pick from. So I mean, if as soon as generic types get involved, you can also have overlapping things where it's not even immediately clear which case it actually should be. And I feel with the approach below, I have a bit more control and sanity, because I'm ensuring that my enum cases don't disappear. I mean, if pet was generic in some way, none of these classes would disappear because they would overlap with some existing member.
So if you can do a type check, why do you need any more syntax than pet equals type cat or type dog?
Yeah, I think from the syntax perspective, I feel that with the approach below, I'm a bit more extensible because it feels like I'm more able to reuse existing language infrastructure. For instance, for the type pet, if I wanted to like define a method on that type, I wouldn't have a good idea which syntax would be picked. But in the enum case below, I would just do curly braces, fun, and
This is just like a classic virtual call. You're making pet enums, like the Java version of the universe is basically pet is
exactly
a class which has subclasses cat, dog, fish.
yeah.
You could have methods in there and they're just standard.
Exactly. It's a bit like I have my classes. I have my standard way of extending my classes with method definitions, for instance, and this enum syntax tries to copy that one-to-one. And I think with this approach, I wouldn't be sure how to properly define it. I mean, you can't do something like this because it's totally confusing whether the curlies to which part of this thing the curlies belong. You could do something Rust style like this. I mean, this would be possible, but I'm not really a fan of that. Yeah, I just want to report that based on your feedback, I had a few ideas, came up with
the Java version goes like your green set, except you put the fun X would be in between pet and cat. And then cat can have some stuff and dog, but they're inside pet.
Right. The difference is that Java enums are enum values. They are, for all practical purposes, ordinals with attached baggage, including constant fields and methods, right?
Yeah, but they have methods. They're subclass. I mean, they're class and subclassing. They have methods.
Right, but they're constants. While in Haskell and other language, I think no, not Haskell.
You can have fields that are okay, I don't know. I thought you could have fields and that were not.
Yeah, but they all have to line up. So you defining your interface of the enum, and every enum member needs to have.
But each enum member in Java can have its own fields that are not declared on the enumeration overall, but every field is constant.
Yeah, okay, fine. All right, I believe you.
And the instances are, for all practical purposes, sealed. That is, you cannot subclass the enum or any of the values of the enum.
Oh, okay.
Sure. And
so in Java, you would have exactly one cat and exactly one dog.
Right.
And
okay.
the name would be constant, and the lives and the age would be So
yeah, everything. Yeah. I'm with you now. You want to just not what he's trying to do here. I understand.
And compared to Java, the enum members are not types of their own, so you wouldn't be able to write this in Java. Whereas with this approach, cat and dog and fish are just standard types that can be used in any context.
Well, if you use them outside of the pet enum, and you also have a pet enum, you have the implementation detail of where does the bit go that tells me what I'm looking at. Oh no, in your case, it's just an interface. Pet, you've basically declared pet as an interface of cat, dog, and fish implementing.
Well, it's basically a union, but he's saying behind the scenes explicitly he wants information. He wants another field in the union that says which one it is. 1, 2, or 3. Is it cat, dog, or fish?
Yeah, but if you have a V table, you've got that information already. You don't have to add any extra bits. In which case, you're basically an interface. I hear you. If you're an enum, you would expect to add 2 bits, 3 bits to pick apart the members. Turns out the members uniquely identify themselves already.
If they are references.
If they have a V table. if they're a Java class, a Java-like class, you're gonna have a vtable, and then that's your
Yeah,
type already.
then
If cat is its own type, it probably has something in it that tells it it's a cat-like thing, and that.
yeah, sure.
So with pet, is petness something that you go to the pet concept and you ask if something is a pet, or do you attach a field to the thing saying this thing is a pet?
Yeah, I exactly had this thought below, and I mean, the easiest way to say is, okay, whenever, if I have a cat and I pass it to something that's expecting a pet, I wrap it or box it or put some integers before, or some references, or doesn't matter. That's, and what I was thinking, okay, that's a bit like we are causing a lot of churn, because in most cases you probably pass in some pet and then you immediately deconstruct it again to do something useful with it. And as an alternative to this wrapping or boxing approach, I was wondering, okay, why not pass it separately as an additional argument? And if you think how it compiles down to assembly, basically use a separate register to pass this information. So you have, so this pet thing turns into some kind of reference that's just passed, that's not wrapped or boxed, but you have an additional value that says, okay, this is actually a pet enum, and okay, this is member 1, 2, or 3, and above here would then turn into
Have you looked at
something like
Ziglang's handling for error codes? They're based.
I think they're doing it similarly to a Swift. I saw the it's certainly influenced by Swift, where they basically say, okay, you have this optional value, but we are not wrapping all optional return types into an optional value, but we are passing in the value, and we are using a separate register to actually say, okay, this was successful or this wasn't successful. Is SIG comparable to that?
Well, no, it's not what I was headed for. They'll let you take a series of integer sized or byte sized ranges and renumber them under the hood to not overlap, and then you can run them together in the same enum space, if you will. So he was taking error codes from file calls or not
Okay.
found and e into file and e no space or whatever, and run it together with other error codes from other things. And as long as there were enough bits going around, he would just rename them under the hood and let you have one tag for all of them. It was a way to construct enums basically out of other enums.
All right. Okay, that's a neat idea.
So in this example, the tag can be, this is the reference, if you will, and this is the tag, like another integer which expresses which one you are referring to. So this, if we're talking, this can be a pointer, and this can be an integer which express which one the tag.
It's just I mean, potentially you could have 5 enum arguments and then only use one tag value which like uses the information or uses the required bits efficiently and places them somewhere in there. But yeah, that's a basic idea.
This I believe this is to me the answer. If you declare an enum which it's with some kind of implementation, the enum is the tag to erase to an integer along with the pointer, but it's pointing to at runtime.
Yeah, I'm considering doing it like this on a first approach instead of going the boxing or wrapping route, because
So
I imagine that
this
it's a pain for like for the garbage collector and teaching the runtime.
so this
and
is not exactly a vtable. So this is not a vtable approach. This is an in plus a reference plus a long, if the reference is long approach. Is not the vtable.
I mean, it needs to refer to the enum type in some way, whether it's using the address of the vtable or some other kind of unique integer. It doesn't matter that much. I mean, yeah, we need to have a vtable reference and then shift things around a bit so we have a few available bits for discriminating the value.
It's also pretty cheap in every vtable to have a fixed set of functions at the start of the vtable that are shared by all types in your system. And
It's just
the first one can be what type are you, which could be an ordinal. So it's like that's your hashconned type identifier and so on. So it's I know it sounds a little bit like a COM, but the Microsoft COM shit. But it works.
I don't see the approaches that different whether you're using the vtable or some type identifier. In the end, the one points to the other. So
right,
yeah,
because you definitely what ends up seeming to be a pattern to me is you definitely want like the generic, not surprising cost way of going and getting that data. Like, what is your type at runtime? But you also want ways of skipping all that. Like, so you might add a byte to the union so you don't even have to do that. Like, in other words, you might have a fat pointer that carries the information. It's like, okay, I know this is discriminated. I've got 3 different possible, I've got fishes and cats and dogs. So I'll use 2 bits in the fat pointer, to indicate which one of those it is, and then I don't need a separate register, for example.
Yeah, that's for efficiency.
Yeah, that's an option. I'm not really sure whether this would work if cat and dog was not a reference type but a value type. And I feel this approach is more independent of that concern. But
by value type specifically in this case versus reference type, you're saying
that the bits are directly, if I'm passing a cat or dog, the bits are directly embedded and it's not a reference passed around.
Right. Yeah, and so we purposely hid that decision so that everything feels like you're using a reference, but it allows us still to pass stuff by value. So
yeah, I'm not sure whether making a decision for the enum case to use fat pointers would inhibit the VM from making a choice whether it wants it's like a handle, whether it wants to treat it like reference type or value type. That's my concern. But yeah, I haven't tried it out enough. It's I think I have still a long way to go.
I mean, the challenge is that if you're not super careful, the difference between values and references show up quite quickly in user code, right? So the only way you can hide the difference is to very carefully hide it from the get-go, right? So so in it's the JavaScript triple equals example, right? Like is it really the same reference? I think they have quadruple equals now too, right?
I think so. Yeah, I think that it's really unrelated, but the thing I'm working on has like let's call it
So,
As something like this, which compares the reference on reference types and the bits on value types. So it's not 100% perfect, but I think from a runtime, from a VM perspective, it's sufficient to paper over the details. Yeah. All right, I
Alan?
think all I had to show today.
Alan, do you have a question? Yeah.
Oh, I just wanted to mention the rock example, which if you scroll down, is there. So rock, it's like this new language. So what he's doing is he has tags, which are just values that live in their own space. And then you declare types that are composed of groups of these tags. So like they're sort of like abstract data types, but they're also not, because you can use the same tag for multiple types. So like here you have cat, and it's in this pet data type, but it's also in this pet2 data type, but the pet2 data type allows declaring a fish as well.
So would a cat value of pets be compatible with a cat value of pet2?
That's a good question. The answer
I mean
is,
that
I'm guessing you'd have to parse it. You'd have to do like a case match over all the values and then return to the same type, I'm guessing.
I mean, because otherwise it would just be like this and then a pet2.
Yeah, just cut and paste.
Yeah, but I have. I mean, it would be possible to implement it, but also, but if you, but only if you're like also careful with the ordering and making sure things line up.
Yeah, well,
So
the difference I think is that instead the tags don't have any types of the fields associated with them. It's all in the main pet type. So like, but you can still use the tags between the types. So that's where I think it's useful. Is that you don't have this like strict. I mean, because you have a type that describes what it contains, but the tags can be used in an arbitrary type, like they are.
Well, all right, yeah, but the pet and the pet2 cat are the same, or they're different?
Well, I don't know. I mean, in my language, they're going to be the same. I don't know about rock. Rock has like so many bugs that it's probably going to change several times. So.
All right, fine. All right, I need to be done.
All right.
All
Oh,
right.
2-week rest.
2 weeks, yeah. And I will come back, I'm certain, with a whole lot more suntan and a whole lot more, well, you always have fun memories, it's fine. Be good stuff. All right.
Okay, you guys, bye. Next time.
Come back with your
Bye-bye.
voice too.
Have a nice holiday.